Hello, everyone. Today we are going to be talking about section 10.3, which is arcs and chords. Our arcs and chords are points on a circle, determine both chords and arcs. Several properties are related to points on a circle. When a minor arc, remember that that's something less than 360, and it has two letters naming it. So when a minor arc and a chord share the same endpoints, we call the arc of a chord. An example of this in this picture would be RS. So arc RS is the arc of chord RS. So chord RS is right here. RS would be the arc of that chord. In a circle, sorry, yawning. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in this picture, there is a typo on the copy that I'm going to upload. This should say 60. I believe it says 62 on your version. If the measure of arc RS equals 60, so this is arc RS, this would be 60. Find the measure of arcs ST and TU. Well, if you look here, guys, you'll see that the chords RS, ST, and TU are all congruent. So if all of those chords are congruent, that means all of the arcs are congruent. So all of these arcs would be 60. So arc ST equals 60, arc TU equals 60, and that's because the chords are congruent. The next thing we have here is an inscribed polygon, a polygon with each of its vertices lying on a circle. So this is a shape within a circle. That's basically what an inscribed polygon is. It's a shape within a circle. So here I can talk about this shape as polygon RSTU, and we can say that it is inscribed in circle O. So when we talk about something being inscribed, it just means really that it's inside it. Okay, so inscribed is basically inside. In a circle, if a diameter or radius is perpendicular, now perpendicular means like this, okay, it creates a 90-degree angle. If it's perpendicular to a chord, then it bisects the chord and its arc. So that means it cuts the chord and the arc in half. Okay, so right here in this picture, we have circle Y. They tell us that AB, this whole chord, is 60. And we also have this arc AC is 71. Now, the thing that they tell you here that's important is they tell you that a radius, okay, if it's perpendicular to a chord, this is a radius right here. This is a chord. So those are perpendicular. They're forming a 90-degree angle. They show you that right there. That means it bisects the chord. So that means these two pieces of the chord are congruent. So if the whole chord is 60, these two pieces are congruent, then these would each be half of 60, which are 30. If those chords are congruent, then the arcs opposite them should also be congruent. So if this is 71, that should be 71. So now let's take a look and answer all these questions. What would the arc of BC equal? It would be 71. What would arc AB equal? We'd add those together. 71 and 71 gives us 142. AD is 30, and BD would be 30. Okay, moving on to the next side. In a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So right here, they're showing you that these two chords, VW and YZ, are equidistant from the center because they have these two 8s here. Okay, same thing in this picture. They tell us that TR is congruent to TV. that means if they're congruent, then these must be equidistant. So this is saying, okay, they're equidistant from the center, so those chords are congruent. This is the opposite. They're saying the chords are congruent, so they must be equidistant from the center. Okay, so it's kind of like when we talked about the converse, we're switching around what we're discussing. Okay, so now let's look at this. They tell us VW is 20, so this whole chord is 20. Now, that must mean this whole chord is 20, okay? Because if they're equidistant, the chords are equal. They tell us that YZ, this chord, is 5X. We know those are equal, so we just set those equal to each other, okay? So we know this is 20. They called this 5X. We also know that this should also equal 20 because those chords should be congruent. So 5X equals 20. We just divide. X is 4. Okay, for this one here, a little different. They're now taking the opposite. So they told us these chords are equal. Now they're giving us these, x plus 4 and 2x minus 1. If the chords are equal, they must be equidistant from the center. So we can go ahead and set those equal to each other. Let's do the math out here. I'm going to subtract x, and then I'm going to add 1. So x is 5. Okay, nice and easy there. Let's do a few more exercises just to make sure we're good with this. It is a little harder when we have to draw the picture ourselves. Lucky for you guys, we're not in school, so you probably won't have to do that. But I will draw this picture in. Okay, not best at drawing a circle. Suppose a chord is 20 inches long. So I have a chord up here, 20 inches long, and it is 24 inches from the center of the circle. So here to the center is 24. Find the length of the radius. So this is where it gets tricky. So a radius, anytime you have these problems where you have to draw it yourself or you may get problems that look like this, they want to know the radius, which you have to be able to figure out using Pythagorean theorem. So you should have it creating a right angle. You know that the whole chord's 20. When a radius and a chord go into each other, they bisect. So that means that these would be cut in half. So this would be 10, this would be 10. So now you have two sides of a right triangle. You need to find the third side, which happens to be the hypotenuse. It's across from the right angle. So this is your Pythagorean theorem. We're going to plug in 24 and 10, and we're going to solve for the radius. It just wants us to find that radius. So now I'm going to use my calculator. 24 squared plus 10 squared gives me 676. And then I'm going to take the square root, and my radius is going to be 26. So that would be the end of the problem there. You've solved that. Okay, so I don't think you'll see too many of these problems, but you may see one or two. In the next one here, they want us to find x, being given the fact that this is x. If that's x, guys, we also have to call this x because these chords are congruent, so that means that these arcs should be congruent. So if that's x, then this is x. You also were given that this arc is 70. A whole circle equals 360. So let's take away that 70, okay, from 260, and we're left with 290. We need to split that 290 into two equal parts. So now let's just divide that 290 by 2, and we will get 145. Okay, so these are two equal parts. You have 70. All three should add to 360. Okay, the last part down here, we have circle G. Okay, they tell us here that DG is equal to GU. So this is 3, that's 3. AC, this whole chord, is equal to RT. Okay, and these are radiuses bisecting those, so that means these should also be equal, and so should these. Okay, so this should be 3, that should be 3. Those should be equal. We don't know what they are, but they should be equal. Okay. We also have right here a right angle. This is a right triangle. So if I have 5 as my hypotenuse, 3 as my side, this is for this segment here. I need to find this side. Why don't I go ahead and try to find that, because I think they do ask for TU first. So let's use the Pythagorean theorem here for this right triangle. I'm going to shade it in so you can see it a little better. That's a right triangle right there. So I have 3 squared plus x squared equals 5 squared. The 5 squared has to be in where the hypotenuse would be. It has to be after the equal sign because it's across from the right angle. So now I have 9 plus x squared equals 25. I subtract 9, I get x squared equals 16. If we take the square root, we get that x is 4. So TU is 4. Now they also wanted CD. They told us the entire thing. Well, we know half of it is 4, so the whole thing must be 8. Okay, so we know this is 4, this is 4, this is 4, this is 4. So we solved for TU is 4. They told us this chord was equal to this chord, and we know that they're being bisected, cut in half, okay? TR, the whole thing, it should be equal to CD. So that should also be 8. And GD, I think we already labeled, it should be 3. Okay? All right. Hope you guys have a great day. Remember, I'm there for office hours 11 to 12.